Makes sense.
Yeah, good. And I saw your progress, Joshua. So
Yeah.
getting there?
Yes,
Yeah, I have this little device.
there he is. Yep.
Uh-huh. The
You
little
you
calculator, which is fun.
you made the program, or you downloaded the program and then you compiled it?
It was a Arduino program that I got from a GitHub account, and then I just downloaded it and modified it a little bit because I didn't like what it had on it.
Mm-hmm.
But yeah,
Oh, that's good. Good.
it was trouble. At first, I had trouble connecting it to my PC because it wouldn't recognize the board. But then I switched the cord to the cord that actually came with the M5, and then it worked right away.
Okay.
Yeah.
It
It's in
could
there
be
There's a lot
also,
of those USB cords that are just charge only. They're missing the actual data wires.
Oh, really? That
or
makes
it is
sense.
or it is too long, so your USB get timed out and then they don't connect. I've had it too. Just a short different cable and conk directly.
Yeah.
Or driver
Uh,
can happen
yeah,
also.
I had to download some drivers too.
Yeah.
Right.
Yeah, but it's such yeah, it was annoying that it was just the cord. I was looking up everywhere what the issue was, but it was just the cord.
Oh, that's normal. We all
Yeah.
know that.
Yeah. Sometimes it's the simplest things.
Yep.
Mhm. And you're using VS Code with
Yep.
Platform IO?
Mhm.
Okay, that worked out good. So
Yep.
you're up to speed on that.
Yeah.
And did you try to compile the code for the Zen itself?
I didn't because I don't know. So if I download the code and run it in VS Code, I can compile it, right? But can I also put it on this M5?
Oh yes, directly.
Oh,
I mean,
absolutely.
it's very
Gotcha.
easy. It's
Gotcha.
if you got platform IO running and then you say just burn it. I mean,
Yeah.
And which branch, does it matter which branch of the bGeigieZ?
The current one I'm working on that uses the GPS is called
I think there's links in
NSSUBN.
in the Slack channel. You can just click on the link and what you should do is you should just get the whole branch, and then you can switch between everything. You can just
Yeah.
go into Visual Code and you can switch it. Maybe I can
Gotcha.
share while we're waiting for Yellow to show up. I don't know if he will show up, but I think he will show up. But I
Yeah.
can share my
So
code.
basically, just you clone the repository. I don't know how familiar you are with GitHub, but the idea is it's distributed, which means that there's a copy somewhere, but it's not necessarily the master copy. It's only the master copy because we agree that it is the master copy. And when you clone it, it's exactly the same thing, except now it lives on your machine. And from time to time, there's Rob,
Yeah, I
thank
can
you.
show you. That's easier. If you can
Yeah.
just here, you can switch a branch. It's that simple. I
Gotcha.
wanted
And
this
then I
one,
could,
and then I compile it. That's it. You run the compiler at the bottom, and it goes boom. And then if you want to burn it, you press the upload key, and it goes.
it's that easy. Okay, well,
That easy.
Oh yeah.
nice. That's the only major question that I had. Just because like I'm not familiar hardwire or using hardware with such a large amount of code. And so I didn't want to like download it and then upload it to this. And I don't know, I was just scared. But
Well,
that's nice that it's that
You,
easy.
you don't have to be scared. It's difficult, very difficult to break. And we have backups. I mean, we can roll back and forth. So
Cool.
don't
Yeah.
worry. Don't worry
Cool.
about breaking things. That's good to break.
Yeah.
Cool.
The nice thing about Platform IO is it really is really makes the Arduino environment actually usable.
Yeah.
It basically it does a lot for you, and basically by taking care of all the housekeeping and all the little details, really lets you focus on the problem at hand, which is
Yeah.
it's not a matter of like some people get, well, that's for lazy people. No, it's for people who want to get the job done.
Yes.
Yeah, I like Arduino, but when doing the calculator for this, I had to transfer it into C++ to use it in VS Code.
Mhm.
And I think I think it makes a lot more sense than Arduino coming from like
Well, Arduino is a C++ under the hood.
Yeah.
It's just they hide all the ugly little details, but it it's using a full C++ 2011 standard. So it's just that they have for hobbyists and artists and newcomers to the whole physical computing, they kind of hide a lot of the ugly details, right? So but if
No, you don't want to hide that. You want it. For example, if VS Code, if you right click here, you can go from definition where it comes from.
Yes.
What it does.
Really
This is amazing. I mean, if you go to this and it shows you all the things, it goes to the other another file, and it's just, I mean, it's so much easier than Arduino. Although Arduino version 2 is not so bad, the IDE. I use it sometimes.
Oh, really?
Yeah. The new version, the newest 2.12, I think. This is a big improvement. They're slowly getting to the same format as VS Code.
Gotcha. I think the biggest thing that that's kind of scared me in sense when I was gonna upload the code to the M5 is that I saw in some of the files that it had the include Arduino.h, and I don't know if you needed the rest of the bGeigieZen pieces to be able to have that correspond one another, or if it's just all uploaded on the M5 and it knows what to do.
Well, M5 stack actually imports or includes Arduino. In some cases, you don't need the M5 stack. If it's just a utility function, then you just bring in Arduino, and then that just pulls in a whole bunch of stuff. And VS Code will tell you if you're missing something. It'll it'll underline the problem and try to give you as much of a hint as possible. So
if you have a problem, if you with compiling a problem, if you in this area, you will see an error showing up. Then you can just often with control click, you can go to the code where the problem is. Just a control click on it, and then it goes to the numbers exactly where the problem is, and it shows a red underline and things like that. So it's it's easy to troubleshoot.
Cool.
And
I'll definitely do that tonight then.
And also another very useful thing is this small thing in the bottom, the serial monitor. I don't have anything connected, but you can just pop it up and you see the serial monitor, like same as an Arduino.
Oh, does that show you what port the device is on?
Yeah, but now in this case, it's the port is off because I don't have the device hooked up. But if there is a hookup, you can see the serial monitor. There's also a small hack for it that you can use. You can send commands. You can send and receive. It's a little bit setup you have to do, but it's not so complex. It's somewhere in the bGeigieZen history. Jelle and me worked around that for troubleshooting the bGeigieCast. In the bGeigieCast, we want to see the output, what it's getting in from the. You're familiar with bGeigieCast?
A little bit. I know the functions of what it does, and I know when we went over in June that it has different stages or phases, I guess. And so I know like the basics behind it.
Okay, so basically the serial data comes in, it gets processed, and it sends it out by Wi-Fi. And by doing that, we want to know what exactly comes in. And normally there's no USB on it, but with the new M5 stamps, they have a USB on it. So the latest version from the bGeigieCast, we're using M5 stamps. So we can get the USB-C get output, so we can check that output. So that's what Jelle and me have been working on for a while. I mean, it's basically Jelle's project. He did it from the start. It's now we're integrating it in the Zen. So it's one of the things we are working on.
Gotcha.
Okay, and I saw Louis had a lot of work done for the GPSs. Can you give a small summary? Louis.
My pleasure. So I think the big decision that was the breakthrough is to totally ditch NMEA format sentences or output and go directly to the proprietary uBlocks protocol. So back to the let me back up a little bit. This bGeigieZen BN880 is actually a module that's composed of the little antenna on top, right? The little ceramic antenna, and just underneath that is a u-blox, it's a Swiss company, receiver chip, and then the whole thing on a little circuit board that you solder in and all that. So u-blox has its own proprietary protocol. It's not very human readable. It's all binary, and it was designed for very fast communication between the host, in our case the M5, and the actual receiver chip. That receiver chip does a lot for us that the NMEA protocol just didn't give us access to. The protocol, I read one description of the protocol. It was, it's like good enough for boats where you want to get within binocular distance of a buoy. So, but if you go to the UBX protocol, which is, I mean, here's the Bible. Can you see? So it's 475 pages of good fun. But it's extremely well documented, and I won't say it's a pleasure to work with, but you don't have to guess. The documentation by this company is very good. The downside is that we're locking ourselves into one manufacturer, whereas the NMEA is generally, is fairly universal protocol, even though it's kind of broken.
But
however,
Louis,
yeah.
hold a second. The u-blox are in many other devices, not only in the GPSs, and they are also in other 3G, 4G devices. So maybe it's useful to switch.
Yeah. Okay. So, well, I mean, yeah, we can identify a few likely replacements. Anyway, so long story short, there's a UBX protocol engine published by SparkFun Electronics in Colorado. And it's open source. It's MIT licensed. And so we're free to use it, and it is a lot more programmer friendly. So you know exactly what you're getting when. Thanks to the u-blox. What they've done is they've taken the u-blox protocol and actually implemented each command as a struct, and then with the elements of the struct being exactly the same thing as the fields of each packet or command or response. So from that point of view, it's just a pleasure to use. The challenge now is to figure out how to best take advantage of this window that we have into the device to get confidence. So the idea here is to basically the goal I'm looking for is positional accuracy, consistent, and this is something that we couldn't get with the NMEA, is position and time as accurate as possible, and the time correlated with the position, so that with the NMEA there was a chance of having a 1 second lag between position and then you're given the time, right? And there's 1 second between each observation, which is obviously not desirable. I mean, if you're walking, it's not a big deal. If you're driving, then yes, there's going to be, like 1 second, you could be traveling quite a lot. So that's the plan right now. I'm just basically going to refine the GPS connector into two components, right? So we're really thinking of two pieces of information. One is date time, and we need that quickly so we can create a file name with the appropriate name, typically, date, and append to that. So we need that as soon as possible. Nice thing about that, we only need one satellite to give us the time, right? Because I mean, yeah, if we're not down to the microsecond, I don't care. I'm just looking for a month and day. Beyond that, if we need a reliable 3D position correlated with time, as early as possible, such that we can start logging without a delay. So if I from that point of view, if I just fire up, I mean, if I left my bGeigieZen Nano on the desk for a few weeks and then fire it up, it can take quite a few minutes to get its first position. And that's inherent in the GPS or GNSS protocol. By the way, I'll be using GNSS as a generic, so a global navigation satellite system, because there's like 5 of them out there now, or 5 or 6. American, the old Soviet Union, Galileo from Europe, Chinese, and now India. China and India are regional. They don't cover the whole globe, but you have to keep that in mind. Anyway, sorry for the side trip. It's inherent in the protocol that it takes a little while for the receiver to learn the position of all 32 satellites in the constellation. And the bit rate is actually quite low. It's 50 bits per second. So it takes about 12 minutes to get all the information. Once it's got the information, it stores it in battery backed up RAM, so that if you're just, if you turn it off overnight and start driving again next morning, all that satellite orbital information is still there. And even if the satellite's drifted a little bit, it's very quick to reacquire a position. So within, like within a minute or less. So from that point of view, we can do a lot with this module and have a user just basically, pick it up and it's there. So what else? So date and time, or sorry, very important, and then fix. And we can also get a degree of confidence with the position. The other cool thing about it is that we have access to what's called augmented GPS, which is basically not only do you have the satellites whizzing around in a high inclination orbit, so they cover the whole world, but there's also geostationary satellites that also transmit time code as an additional reference, fixed reference, because those positions are well known. They don't go whizzing around. They're equatorial geostationary, and we can get depending on the quality of the signal, we can get within a few meters position. So I'm excited about that.
That's
and I've
great.
learned a lot more about GPS than I ever wanted to know. It's cool.
That's good. That's good, yeah. That's very useful.
Yeah.
I mean, I never digged into it like you do, but yeah, very much appreciated all the work you're doing. It's good.
Well, it kind of worried me, when ASBE was reporting,
Drifting all over
the place, and it's like wait a second, like we want high integrity data to go into the map, please and thank you.
Mm-hmm. Does it help? Does it help also with the reflection from buildings? I mean, that was one of the main issues. Yeah,
the urban canyon. I haven't dug into that. The good news is that the Japanese Space Agency has looked at the problem, and their solution is to park some satellites. They're in they're not geosynchronous, but they're orbit, but they're basically the orbit is geosynchronous, except it's a high inclination. So what it does is, over Japan and Australia, since they're pretty much at the same longitude, it describes a little figure 8, so that it's always very high in the sky, so that you can actually see the satellite despite an urban canyon. The multipath reflections, bouncing off buildings, and have basically a part of the signal arriving late with respect to the direct line of sight. I haven't dug into that yet. Let's get to point A first, but it's definitely in the to-do list. Obviously, with with everybody else's satellites, they don't have that high angle satellites. Basically, the Japan basically made the decision to have some satellites visible, even if you're in an urban canyon. So,
And that's for the Tokyo Osaka area or all Japan.
oh, it's basically all of Japan and Australia, because
Yeah.
this thing just
Okay.
moves
So
up
it's
and
pretty
down.
great. So like that. Yeah. I can imagine
Yeah.
that.
It's moving, just to a little bit north of Japan to cover Australia, because it has to, because the orbit is inclined.
Mm, I understand. Yeah. Interesting. I didn't know that.
Yeah, that's cool.
Yeah.
Yep.
So they call it quasi-zenith satellite system. So
And you need a special protocol to access them, or you can just figure them out which one they are.
the receiver does it for us. All we have to do is ask for it.
Huh.
This is why, like I say, going into the UBX protocol just opened it right up.
Yeah. And
Right.
it was not implemented in the Tiny GPS plus.
No, because Tiny GPS only looks at NMEA
And doesn't have that.
lenses.
That's correct. Yeah.
And as I say, if you want a good critique, it's actually quite vicious. I don't know if you ever heard of Eric S. Raymond in the Linux world,
Yes,
ESR.
I heard about it.
Yeah, well, he's actually working on the library or a daemon. He calls it the GPS daemon for Linux and whoever else. And he's had to implement basically protocol engines to talk to all sorts of different. When he talks about a GPS mouse, which is basically just a little receiver with a USB cable, and he just has a completely vicious cut up of the NMEA protocol. It's actually quite entertaining. I mean, if you're into that kind of humor.
Yeah,
So,
cynical. Yeah, black market. I can imagine that.
yeah.
We still have maybe 10 minutes to go. So what should we do? Should we wait? Seems like Jella is not joining today.
Okay.
So
I do.
Yeah.
I do have a question. I posted them on
Slack.
Slack. Sorry.
Yeah, no, that's okay. That can happen.
It's the I was noticing when I was looking at the maps that ASB was publishing from Kiev and Chernobyl, that there is actually at each point there's also a heading, and I'm just wondering if that heading is added in the post-processing when the drive file or drive log is uploaded, because I couldn't see it in the regular protocol. And thank you for that link. I did get it. So that was my one question. Second question is, there in the bGeigieZen mini page that's linked from there, there's another protocol definition called NX, and it has an extra record on the end, which gives let me just go back to Slack to see my notes here.
Not an extra record. You can make a second line, and yes, second line. I use that for sending gas data for air nodes for beginning, maybe a while back when I made a test for Rakuten for bikes with environment sensors on it. So the second line you can use for that.
I see. So
and there's a thing called SXT, something like that, and it has not a string like a B, a $sign B, but it has a $sign S, I think, on it. I'm not sure. It's something like that.
Yeah, that's not what I was referring to. Is there's in the same BN?
Yes, NX is something different. There's an I don't know where that field is used for. I've seen it.
Yeah, it says the last field is fix quality. That information is available from the module. The question is, do we want to add that to the drive logs? And that's a question that I really can't answer. all I'm just gonna I'm saying is that it's available. It's no big deal to put it in.
I have to
Because
look at the code for the filtering that's being done for the API, and
Yeah.
the API and ingest are a little bit different filters to the API has a database, and ingest is the main big database, the new one. API is an
Mhm.
old database basically, where we get the data in, and it's filtered out in the gateways, and the gateways
Okay.
are basically designed by Ray Orsi. And
Okay.
there's a lot of code in there. I mean, it knows if it's a bGeigieZen Nano, it knows if it's an air node or a RUT node or anything else, and then it filters differently.
Okay.
They have to be careful with that, because sometimes if there is zero CPM, then it does different things. I mean, it's like
Right.
the sensor is off or something, and we have to check that. And sometimes we just have to mention it to Ray, and then he will look it up, and then he will figure something out.
Okay.
And we can,
Good.
if you want something special, we can do that. He can do that too.
Yeah, I think I'll connect with him and get an idea of what information would be helpful. So
You
that's
can
basically it.
look also yourself. Huh?
Yeah.
There's
True.
the code is open for the gateways.
True. 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 True.
It's in
So that's
T node, I think it's called.
yeah. The so the now I made a branch off of Yella's sensor reporter framework, but it doesn't seem to generate a log file, and I'm just wondering about that.
Maybe we should ping Yella about that. That's
Yeah. Okay.
maybe the easiest, or make a note in GitHub or a comment or an issue. I prefer
Okay.
that we start to use more issues and track it on the main project. Then we can all see what's going on and what needs to be done. But,
Okay.
I'm sloppy myself. I mean, I should put more things in that too.
Yeah.
I didn't do it yet.
Okay. Well, that's it for me. So
Okay. And Josh, you are okay with the issues and the project for GitHub, what we set up?
Yep.
So you can
Yep.
make notes and issues, and you know how to use those? Because that's
Yep.
very important. I mean, if you have issues, make a list, and we can
Okay.
talk over it. And if you have questions, that's the easiest place, because then people can go track back what we've done. They don't have to use Slack for it. So
Okay.
they can always, everybody can see what we've been doing. And that record keeps. I mean, it's not like Slack that you need to have access to it, but everybody, it's open thing. So I prefer that.
Okay. Yeah, I just created a new fork of the project. I think I might have only forked over one of the branches, so I just made a new one, so I have all the branches now.
Yeah, and any questions you have, you can post in the channel, or you can approach me, Yella, or Louis directly. I mean,
Okay.
Louis and me are more available these days than Yella, but Yella is basically the main driver for the new code.
Gotcha. Will do.
And take your time.
Okay.
Study is important.
Yeah, I think that's what I'm mainly going to focus on this week.
And don't worry about breaking things. I mean, you know, it's the copy of the code is on your machine, and it's not going to affect the main repository. And if you break something, you always back it out.
Gotcha.
And also we can roll back. I mean, so don't worry about that. So if you make a mistake, I prefer that you make 10 mistakes and get one good result than you are afraid to make mistakes. Just stumble, and you will get there. It's better.
Yeah. So
Okay, I'll keep that in mind.
Okay.
Thank you.
We've
okay.
other things to discuss. Oh no, you had two questions. You said.
Well,
Louis.
yeah,
The
no.
other one I didn't reply on.
Well, the one was the heading that I see on the map, and the other one is this extra field, the fixed quality.
I think that the heading is being used, I think, for the air sensors. And
Okay.
I think Nick uses that for calculating certain things for the air sensors. If you see the graphs from the air sensors on the map, air
Okay.
sensors have different graphs on the map. If you saw that, I don't know if you clicked on them.
Yeah. So, okay, well, I'm just gonna worry about, just replicating the actual record. So, basically I'll connect with Yella. Maybe I'll just, jump in and have it generate some log files. Anyway, because that's all, it's all sort of interlinked, right? There's the startup. So we're looking at for the SD card, we're looking for the configuration files, like safecast.txt and the bGeigieZen.
The text, the text files,
the two configuration files. We're trying to make sure that there's an SD card there. We're trying to make sure that GPS has it fixed. So there's kind of this sort of this big whole bunch of operations that have to happen before the user even sees a screen. So yeah, so that's worth looking into.
We have
37 seconds.
Okay, we say goodbye.
Bye.
And talk to you later. Okay. And
Talk to you
enjoy your time being. Yeah.
Thank
Okay.
you.
Okay.
Bye.
Bye-bye.